Hello everyone, thank you for joining us today and finding time out from your busy schedule to attending our webinar. Today's coffee talk, which estimated 30 minutes, I'm going to talk about Spark on Azure, more precisely how to run Apache Spark pools on Synapse Analytics. According to Synapse Analytics, I have a coffee talk previously with the name of how, where and how to store your big data, which you can find in our platforms. And please feel free to leave your comments and questions in our platforms. Today's agenda consists of brief topics like how Synapse Analytics manages Spark environment and what we have with Synapse Analytics Spark pools, which is one of the main computing resources in Azure Synapse Analytics. And next we have talk with Synapse Notebooks. We are going to have a demo on this theme. And of course we are going to talk about Synapse in Synapse Spark tables. Let's mention that Apache Spark, may you familiar with it, but Apache Spark is an extremely powerful in-memory analytics engine which is built in a cluster computing technology. That means for running Spark engine we need a cluster. You can run a Spark engine in one single machine, but in a business point of view the machines should be at least two. And these two machines, which each machine we will call nodes, consist of cluster. And the data which processing with Spark is running on this cluster's memory. Recording about Apache Spark, it's a powerful system which performs large-scale distributed data processing with wide data like structured, semi-structured, even structured data. They will have a highly scalable and fault-tolerant architecture, which is one of the main important features Spark that people like it more, which allows to run hundreds and thousands machines and recover faster from failures. And we have a widely used cases with Spark. It's batch processing, stream processing, machine learning, advanced analytics, and so on. With Spark we can use Scala language, Python, R, Spark SQL. Let's mention that Scala is a native Spark language. But next we see with Synapse Analytics we can use C# too. Let's talk about a little about Spark high abstraction, which is a data frame. Data frame is in-memory data structures of Spark, which explore and process data in memory, and it consists of like database tables. It consists of rows and columns. Next we have widely operations with data frames like adding, removing, editing, renaming our columns, and of course we can have filtering, sorting our rows. And next, with data frames, we have in Spark we have optimization operations, which allows to faster data processing in data frames. Let's digging into Apache Spark architecture. Here we have a driver node and worker nodes. On driver node runs data processor, which coordinates executors. Executors is Java virtual machines, JVMs, that runs on worker nodes. Each worker node can have at least one executor, and on worker node can have at least one core. In this example, we have executor on a size 2 cores and 14 GB of RAMs. And let's assume that user want to read the amount of data from data lakes. This job we send to a data driver processor, which estimates parts, into parts, this wall data, and as a task sent to executors. And how many cores have executor, so that's mean he can parallel run that count of tasks. So in this case, we have 3 parts of data reading and have 3 cores which runs simultaneously, as in diagram you see. And let's mention here that task is the smallest unit which can execute on Spark engine. Let's see what Synapse brings to table with Spark. As we say, it's an in-memory distributed processing of data. And here we have, as we have from Spark, Scala, Python, Spark, and SQL, we have here C#2 and our language, of course. And we have the same use cases. We can use it for batch processing, stream processing, of course in machine learning, integrated with Azure other machine learning systems, and of course advanced analytics, which is one of the main point of Synapse. And additional features that we have with Synapse, first is multiple Spark pools we can run in few clicks. You don't need to care about even libraries that you need to install on your environment. So we have pre-installed libraries. And next main features that suggest Synapse is auto-scale pools. So you can have pools that you don't run at the same time, and you don't need to pay for it. It allows to save your money. And next feature is, of course, allows to save money, which is auto-terminate pool. Here we have Spark integration options with Synapse. On a data source options, we have a dedicated SQL pool. Next, we have data lakes, and of course, widely used Azure Cosmos DB, and etc. Next, we have built-in support from Hive, parallelized notebooks, and of course, Synapse pipelines, which allows to build widely ETL and ELT pipelines. Next, we have connected services. As I mentioned, you can connect your Spark pool with Azure Machine Learnings, with now widely used cognitive services in Azure. And here we have in preview hyperspace feature from Microsoft, which allows to indexing your data in data lakes. Next, let's talk about, as I say, about notebooks, how we need to work with notebooks. Let's mention that you work mainly with notebooks. You write your code in notebooks, and here you can use all languages that support Synapse and Sparks. And each notebook, let's mention that is have some isolation. That means each notebook can have isolated resources, can work separate Spark pools. And here we have visualization feature, which allows to, if you have tabular data, you can instantly have charts on this data and graphs, of course. Next, we have a collaboration feature, which allows to multiple users use your notebook simultaneously at the same time. And as a developer, as a data analyst, you need to have a monitoring tool sets. Here we have native Spark UI and Livy. Let's see how we work with it. For example, user create notebook 1. Before he can run this notebook, he needs to allocate resources. Let's assume that user choose Spark pool from small types, and in here we have 2 executors and of course one small driver. So executor size on a small option, we have 4 virtual cores and 28 GB of RAMs. So here we have 2 executors, and let's notice that each driver size equal to our executor size. That means totally we have 3 times 4 virtual cores and 3 times 28 GB of RAMs. And as you see in the right side of my slide, our 3 nodes allocate only 12 cores for current job. And the final, I want to remember about Spark tables. In a Synapse, we can create Spark databases which contains Spark tables. Let's mention that these tables don't store data. These tables only link to data that stores in external sources. Next, we have Hive Metastore, which integrates each workspace. You can store your tables in Hive Metastores too. And of course, let's mention that you can work with widely used tabular formats, files, CSV, JSON, Parquet, and hence you define your tables, you can run it as a data frame. Now let's go to in a demo part. For demo part, we need to, let's start from first. Let's leave this. As you remember, we can go to Azure Synapse Workspace without entering Azure portal. We're going web.azuresynapse.net, and here we have we should choose our appropriate subscription and pre-built workspace and click continue. Here we have Synapse Analytics workspace. For creating new Spark pool, we need to go to Manage Part from bottom of the list left, and from here from Analysis Pools you should choose Apache Spark pool. And as you see, I have created one Spark pool. Let's create a new one. It's very easy. Let's copy previous name, click new. Here we need to name our Spark pool. Let's 002. We have only one choice, memory, not size family. It's memory optimized. There are no choices here. So first we need to choose our node size. Here you see we have small, medium, large, X large, and double X large choices. Let's choose medium size with 8 virtual cores and 68 gigabytes. And here is a big feature, auto scaling, that let's enable it, and it enables us to determine how much cores we want to use in our peak when we need to run more tasks. So you can here put your maximum, that's 10, it can be, and here our estimated cost. That means when we run with 3 cores, we will pay hourly 3.7 approximately $, and when we run with 10 cores, our cost will be 12. Let's put it as it is, dynamic, and from here you can choose your automatic pausing, which allows, of course, save money when you don't use your pools. It's go to pausing and you don't pay for it. And let's 20 minutes for our demo. I think it's okay. And here you have widely used your versions of your languages which you are going to use with Apache Spark. From here you can choose your version which you prefer on Apache Spark, but let's stay in a final version. And here we have some configuration for more detailed Apache Spark engine. Here is our final preview. Let's create it. This takes approximately 1-2 minutes. Let's wait it. This deployment. Until it deployed, let's go to portal and see that when we're creating Apache Spark pool, it's as you see, it's here. It's created. It's additional service, additional resource created on our. Let's refresh it. Maybe it appear. Okay, we will back. Okay, here is our pool. Now let's go to develop part from here, and let's create our first notebook. Let's click on the plus button, click notebook, and let's hide this part. We don't need. Let's name our notebook. Let's take notebook 1. Add the description for development purposes and hide it. And on the right top section of screen, let's click on configuration our session. We need to attach Spark pool to our notebook. Let's choose our 002 Apache Spark pool. Here is, it shows us that it's a medium size with 8 virtual cores and 56 GB of RAM. That's mean we can have 9 executors and 1 driver node. Dynamically allocate executors. Let's disable it. Let's put a minimum size of executors. Driver size will be, each driver size will be 8 virtual cores, and that's fine. Session timeout 30 minutes. Okay, let's click apply. And here is, you see, we have attached our Spark pool to our notebooks. From here you can choose your preferred language. Let's take Python. It's, I think, very popular and you may like it. Let's run our Spark pool. First type hello world. It takes some minutes, around maybe 3 minutes, because of it's now starting session. Now it's allocate resources that we define for our notebook. Until it start, let's refresh our resource group. Here you see we have our Spark pool as an additional separate resource. Let's click on it, and here you see your minimum settings that allows from Azure portal. You see here we have package settings, Spark configuration. Anytime you can configure your Spark from here, of course, and other additional alerts, monitoring, and other. Let's go back. This takes, I think, 3 minutes round. From here you can add your notebooks to your pipeline and run it on your ETL pipeline. And you can see from here your variables. I don't want to click now because of loading process now started. And if you want to save your notebook, you can publish this, and every time when you I will go to your Synapse dashboard. You can see it, find it on developer part on your notebook set. After starting our session, it will be worked very fast, I think. I want to remember when you're creating Synapse, you need to create a storage account with data lake purposes. Let's click on it. Here I am store files on tabular formats like Packet and JSON. I have, as I remember, here is my files, in which approximately we have 1 GB file, a CSV file, and here it's a JSON file. We are going to read data from these files and analyze them with the help of Spark pools. It shows me that ready, but loader still loading. Let's wait some minutes, some seconds, I think. From here you can click new code and of course Markdown too, and you can add some, for example, your marks. For example, that's title, and choose your style. And you can, it's ready. We can, it shows our hello world that it's ready. You can drag and drop every time you want. And let's see some simple examples. Let's define a sum identifier, for example, 1 + 1. Let's enter, print from this sum. For run, we need to click this run cell or press Shift-Enter into a notebook cell. Here it shows 2. Let's create another one. For example, sum equal sum plus 1. Let's run it. Let's print it, of course. Print here. Print our sum. As I clicked it 5 times, it shows me 5. And each time when I clicked, it should add another one. We can delete these additionals. Now let's add some codes from for saving time, I write my codes here. Let's define a gcar file path which stored our gcars 2022 CSV file location or path. Let's run it. Let's print that be sure it store our appropriate value. As you see, it's stored in our appropriate value in gcar file path. Let's run another task. We are going to read gcar data from this part. Here we define data frame. It's a new literal. On here we have Spark, which allows this variable we are using for accessing our Spark session. And we have here read property for reading purposes, and CSV function because of our file is in a CSV format. And then we want to print our schema. Here is it shows us that it's used 2 executors and 17 cores. From here you can every time go to your Spark UI for monitoring purposes, your Spark pool. Let's back, it's complete, and here is our data frame columns. You see here is only string columns, but let's back to our data lake, choose our file. It's stored in gcars folder. Here is our CSV file. From here you can directly, if your file is in CSV format, you can directly go to, with right-clicking on it, you can go to new notebook and load your it as a data frame or a new Spark table. And you can get your CSV file part from here. Let's preview. And as you see here, we have data format, integer format. Let's we have some options properties methods with the help of which we are going to define our columns types. Let's create additional. Of course, we can add this code in the same unit, but let's add additional 1 unit. Each time it shows us how many jobs it's created, how many executors it's allocated, and cores. Of course, you have 2 options for monitoring from here. Viewing monitoring, it's Spark Synapse. Let's create it, and here, as you see, we have integer types of 2, timestamp types 2, instead of strings. With the help of these options, methods, we here put header and next our schema. Let's add another one. Let's display our car data, gcar data from our. Let's run it. Here is our data that we are storing on CSV file. As you remember, this file is around 1.2 gigabyte. You have here choice with charts. You can configure your chart, for example, line chart. Let's apply it. Okay, let's count, aggregate our count, and you can choose others too. Let's see another one option. We have let's display a summary of our gcar table. It will show columns data each column for each column. Until it shows, let's see what we have. We can export this result in which format you want. And here we have our column names and types. Here is how unique appearance on it We have, for example, in a pickup column, we have 2 million unique data, 2.5 million unique data, and no one is missing. If you're clicking on your row, on the right side, it generates a chart or schema, which allows you to view and your existing values, and it helps to analyze your data. Let's view it. What's happened? Maybe, yeah, there is a... Okay, let's create another one. It's until it's complete. Here we can choose only the selected columns. It's our data frame. On our data frame, we are going to use, let's see, it shows our, on this diagram, we can show your data on this location ID, for example, column. I think it's a useful thing. If your data is in numeric type, you can see here your maximum, minimum values, and here you have another visualization options. Okay, with the help of this method, select method, you can select only the columns that you want, and afterward let's print our schema, and you will see that our gcard trip data frame will change the structure, and it will contain only this selected 6 columns. Let's wait. From here you can choose full screen, and I think it will be more. Here it shows new data frame structure, which contains only the mentioned header columns. Of course, we have options to rename our data frame columns with the help of which column renamed method. Now it's running, and you see we have now renamed columns. Pickup time, I think this is more easy to use. Next, let's see what we have. We are going to create derived columns in our data frame with years, month, and days. Let's run it. It executes immediately. That's mean in a trip year. Here we have trip year. It's bring from pickup time year and month and the day of month, and shows it here. Let's an additional one. For example, let's run we are going to store a JSON file pod here. This variable will store our JSON file, which we have here. It's our JSON file. Let's now read data from our JSON file. As you see, here is our JSON file, and with address and geolocation we have more complex types with street, city, postcode, state, building, and we can run command and have a flat data frame. For example, let's see, in the same literal, we are going to store, in a new literal, gcar space flat, we are going to store flat, so with the help of select method, we are going to license number from base license ID and additional. Let's run it. And here is more easy and flat format our data. That's all that I want to show you. Please feel free and leave your questions in our media platforms. And next week I'm going to talk about connector with Spark and Event Hub. Event Hub is a messaging service platform, PaaS platform as a service in Azure, widely used. And thank you for being with me. That's all.